In this video, I will share with you some very important points about amplitude modulation. For efficient wireless transmission of an electrical signal, the signal is superimposed on a high frequency wave called carrier wave. Depending on the method of superimposition, either amplitude or frequency or phase of the carrier wave gets modified in accordance with intensity of the signal. The process of modification in some characteristics of the carrier wave is called modulation. If only amplitude of the carrier wave is modified, frequency and phase remaining the same, then the process is called amplitude modulation. The ratio of maximum change in carrier wave amplitude to the original value of carrier wave amplitude is called amplitude modulation factor. Now the change in carrier wave amplitude can't be greater than signal amplitude, so amplitude modulation factor can be expressed as the ratio of signal amplitude to the carrier wave amplitude. If amplitude of signal is greater than amplitude of carrier wave, then modulation factor will become greater than 1 and the modulated carrier wave is said to be overmodulated, and in that case there occurs discontinuity in the wave that is not required. Thus, the signal amplitude must always be selected less than the carrier wave amplitude. Now let us come to the mathematical part about amplitude modulated waves. We can express signal by an equation Vs equal to As cos omega st, where Vs represents instantaneous signal voltage, As represents amplitude of signal, omega s represents angular frequency of signal. Similarly, we can express carrier wave and amplitude modulated wave in the similar mathematical equations. The amplitude of amplitude modulated wave does not remain constant, but it varies in accordance with intensity of the signal. So we can write mathematically amplitude of AM wave equal to amplitude of carrier plus instantaneous signal voltage. By doing little mathematics, we can get an expression for AM wave that represents instantaneous voltage of AM wave. This result shows that an AM wave is equivalent to three waves. Number one, a wave of amplitude AC and frequency omega c. That is, amplitude same as that of carrier wave and frequency also same as that of carrier wave. And second, wave of amplitude MAC by 2 and frequency omega c plus omega s. And this wave is called upper sideband. And number 3 is the wave having amplitude MAC by 2 and frequency omega c minus omega s. This wave is called lower sideband wave. It is clear from this result that signal or the useful power in AM wave is contained in its sidebands. Now let us discuss the power associated with sidebands. We know power associated with any signal is directly proportional to square of its amplitude. So we can write the ratio of power associated with sidebands to the power associated with complete AM wave as MEC by 2 square plus MEC by 2 square divided by EC square plus MEC by 2 square plus MEC by 2 square. After doing some mathematics, we can reach at the result that power associated with sidebands is equal to m square by 2 plus m square multiplied by power total associated with AM wave. Maximum value of modulation factor can be 1. So by putting this value, we can reach the conclusion that power associated with sidebands can be at the most 1/3 of the total power associated with AM wave. Now let us come to limitations in the method of amplitude modulation. Number 1 is low efficiency. The previous discussed result shows that maximum useful power in AM wave is 1/3 of the total power. So we can say about 2/3 power is not of our use. Second limitation is its operating range is very small. It is due to low efficiency. Third one is lack of quality. It is due to the reason that all the frequencies cannot be reproduced at the receiving end. Number 4 is the reception of AM wave is very much noisy because all the noises around us are nothing but amplitude variations, and these noises also get received along with the AM wave. Thank you very much.